Okay, I think we are recording, maybe. I'm trying to get my screen to go on the correct spot. All right. Good afternoon and welcome to room 261. This is Mr. DeNeve. We have a lesson today on graphing parabolas. We've been graphing some parabolas, but today we're going to graph some in a little different form. Today, they're in the form y equals ax squared plus bx plus c. And it's only really a parabola if a is not equal to 0, right there. And so we're going to make sure that we at least have a number in front of the x squared that's non-zero. An important fact here is that if an equation is in this form, the x-coordinate of the vertex is the opposite of b over 2a. Okay. And so we're going to do about 3 or 4 together. And after we do that, then you'll be tasked with trying to do some on your own. And so the first one says y equals 2x squared plus 4x. And we're going to graph the vertex, and we're going to make an xy chart, and then we're going to plot some points. Okay? And so the vertex, as mentioned, is the x-coordinate is the opposite of b over 2a. Now, remember, a is the number in front of the x squared, b is the number in front of the x, and c is a number that has no variable attached to it. So in this case, a is 2, and b is 4, and c is actually 0 in this problem. And so x is the opposite of b over 2a, and so since b is 4, the opposite of b would be negative 4, and since 2 is a, we have 2 times 2 here, okay? 2a, a is 2. And so this is negative 4 over 4, which is negative 1. So what we're going to do, team, is that we are going to make an xy chart where we choose negative 1 as one of our x's. And then we're just going to go right and left of that. Since parabolas are symmetric, we're going to go right and left of that. And so to the left of negative 1 is 0. To the right of 1 is 2. Or actually, to the right of negative 1 is 0. To the left of negative 1 is negative 2 is what we meant to say. If we went 1 more to the right, that would be 1, and 1 more to the left, that would be negative 3. Okay, so we are going to now plug in these points to get the answers. So if I plug in a negative 1 for y, or for x, sorry, this would be 2 times negative 1 squared plus 4 times negative 1. And so that is 2 times 1 minus 4, and so that's negative 2. And so negative 1, negative 2 is our answer there. When we plug in a 0, we would have y equals 2 times 0 squared plus 4 times 0, and so that's 0. And so we'll put a 0 here. If we plug in a negative 2, we'll have y equals 2 times negative 2 squared plus 4 times negative 2. So 2 times negative 2 squared is 2 times 4. Negative 2 squared is 4. 4 times negative 2 is negative 8. And so this is 2 times 4 plus negative 8. Well, that ends up to be 0. Okay, I'm going to get a piece of paper here to show my work on the others. So when we plug a 1 in, we would have 2 times 1 squared plus 4 times 1. So that is 2 plus 4, which is 6. If we were going to plug in this negative 3, we would have 2 times negative 3 squared plus 4 times negative 3. Okay, 2 times negative 3 squared plus 4 times negative 3. I'm using this equation, right? And so this works out to be 2 times 9 minus 12. And so 2 times 9 is 18. Minus 12 is 6. And so this is 6. And so now that we've got our points from our XY chart, we're going to go ahead and graph them. So we have x's at -1, at 0, at -2, at 1, and at -3. Those are the ones that we chose here. Okay, and so we plot them. -1, -2 is this one right here. 0, 0 is here. -2, 0 is here. 1, 6 would be way up here. 1, 6. And -3, 6 would be up here. And then we'll just connect the dots. And we know what a parabola looks like. It's this symmetrical sort of U-shaped figure. Okay. And so that would be some A+ work here. It's always good to label your points. Okay. And so that would be A+ work for that first question. All right. Remember, you can always pause the video and watch it again if it was a little too fast. Let's do another one or two together. So on this one, we have y equals x squared minus 4x plus 1. Again, we want to find the vertex. That's x equals the opposite of b over 2a. In this case, b is -4 and a is 1. You could always put this 1 right in front of the x squared if you wanted to. So the opposite of b would be the opposite of -4. And then a, of course, we said was 1. And so this is 4 divided by 2, or 2. All right. So I'm going to write it a little different on this problem. I have a feeling that felt a little helter-skelter on the last one. The idea here is that we are going to make the vertex, and then that we're going to create points on either side of the vertex, knowing that it's symmetrical. So let's go ahead and just put this 2 kind of down here. And then let's go to the right and to the left of 2. And so to the right of 2 would be 3. To the left of 2 would be 1. Okay, and then let's go one more. And so if we went 2 to the left of 2, we'll have 0. And 2 to the right of 2, we'd have 4. This XY chart is just going to look a little nicer. I think you're going to like that a little better. Now, just like on the last one, we're going to plug in all of these x's that we just found into our equation to get the y coordinate. And so, when we do that, I kind of liked having this extra piece of paper over here. So we'll plug a 0 in. So 0 squared minus 4 times 0 plus 1. So that would end up being 0 minus 0 plus 1, so 1. So we're going to have a point at 0, 1. When we plug a 1 in, that's 1 squared minus 4 times 1 plus 1. So this is 1 minus 4 plus 1, which works out to be -2. When we plug a 2 in, we would have y equals 2 squared minus 4 times 2 plus 1. So that is 4 minus 8 plus 1. That's -4 plus 1, so -3. All right. That's our vertex, by the way. That's the one where we found x to be 2. All right. Now when we plug a 3 in, we'll have y equals 3 squared minus 4 times 3 plus 1. So that's 9 minus 12 plus 1. So that's -3 plus 1, which is -2. And when I plug a 4 in, I'm going to get a 1 back. This is 16 minus 16 plus 1. So we have this point here at -2, -3. We have a point at 1, -2. We have a point at, oh, Darren, you messed up. Oh, sorry about that, team. I'm sorry, these are not points. I had my negatives and stuff crossed. All right, let's go back and start over. 0, 1 is right here. 1, -2 is there. 2, -3 is here. 3, -2 is here. And 4, 1 is here. That's much better. So we'll then connect these dots. Sorry again for that mistake. This is 4, 1. This was 3, -2. This one was 2, -3. This point here was 1, -2. And this one was 0, 1. So we have some symmetrical stuff going here. I want you to notice that we have a very similar thing going on both of these problems. So the y-coordinates, to the right of the vertex were both the same if you got the same distance away. Notice that happened here too on the first one. Okay, we have this 1, -2, but then these 2 points both had a y-coordinate of 0, and these 2 points both had a y-coordinate of 6. And so that's going to be a common pattern here if you keep doing it the same way. All right. Let's move on to the next one. The next one says y equals -x squared minus 4x minus 4. The vertex, as described, was x equals the opposite of b over 2a. b, in this case, is -4, and a is -1. Maybe we'll write that down. a is -1, b is -4. All right, I can do that up here as well. A was 1, and b was -4. Perhaps that helps you. On this first one, a was 2, and b was 4. All right. Okay. So here we go. The opposite of b would be the opposite of -4. And 2 times a is 2 times -1. So this is 4 divided by -2. So this is -2. Just like on the last one, let's cleverly make our XY chart. Let's put -2 kind of in the middle here. All right, it's the vertex, and so we're going to go ahead and move 1 to the right and 1 to the left of it. And so 1 to the left of it is -3, and 1 to the right is -1. And then if we go one more, so -4 and 0. All right, so this will be our vertex right there in the middle, and then we'll find the other ones. All right, so if we did the same sorts of things that we've been doing, we're going to plug in these numbers and see what we get. So it's the opposite of -4 squared minus 4 times -4 minus 4. Boy, there's a lot of negative signs there. So this is -16 plus 16 minus 4 when we plug a -4 in. When we plug a -3 in, it's the opposite of -3 squared minus 4 times -3 minus 4. And so that is -9 plus 12 minus 4. So that's -13 plus 12, or -1. When we plug a -2 in, we end up with that calculation that's necessary. And so this is -4 plus 8 minus 4. Well, guess what? That's 0. And just, we'll show you the work here, but just as a reminder of what we were saying before, if we're doing this right, there's some symmetry involved. And remember, this was the vertex, and this was a distance of 1 away from the x-coordinate of the vertex, and we got -1. And so if we're doing this right, we're going to get -1 right here, and we're going to get -4 right here. And so let's take a look and see if that is correct. Okay, so we've got, we're going to plug in -1. So this works out to be -1 plus 4 minus 4, which in fact is -1. So that's exciting. And when we plug a 0 in, plugging in a 0 is really about as convenient as it gets. You'll get 0 minus 4, and so that's -4. Okay, and so those are the points we found. So let's plot them. We've got 4 to the left of 0 we're going to plot, and we got some y-coordinates that are also negative, and so let's do that. And so we've got a point -4, -4. We've got a point that's -3, -1. We got a point that's -2, 0. We've got a point that's -1, -1. And we've got a point that's 0, -4. And then we'll connect the dots as we've been doing. And we'll go ahead and label these points. Mathematics begs to be communicated, we say. So the clearer your work is, the better. This is -1, -1. And so that one is now finished. We should notice that this one, unlike the other two, has a U shape, but it's opening down. And the reason for that, of course, is that that sign right there in front of the x squared is negative. And so if you have a negative sign in front of the x squared, you're going to find that the parabola opens down. Okay, well we're going to let you do numbers 4, 5, and 6 on your own. I would encourage you to look back on the video and try to just follow the same sort of pattern as we've had in the first 3 problems. And then at the end of your packet today, there's some, for lack of a better term, there's some fun worksheets, okay? And they're going to ask you for some answers. And this page here is just, where you're going to put your answers. But you've got this worksheet here. It's like a puzzle, and you are to place the numbers 0 through 9 in each of these spots in order to make it work. And so, just as an example here, you're like, well, how should I get started? Okay. Well, for example, we're going to take some numbers, subtract 3, and divide by 2. And so if we're going to divide something by 2 and it's going to be a whole number, then we need this a minus 3 to be even. But 3 is odd, and so we might reason that a has also have to be an odd number. Okay? And so we might just pick one and see if it works, maybe 7. 7 minus 3 is 4. 4 divided by 2 is 2, plus 3 is 5. And I'm not necessarily saying that is exactly where 7 and 5 is going to go, because it's a puzzle. You got to get it all to match out. But that might be some train of thought that you might have. For example, down here as well, we're dividing by j. Well, that can't possibly be 0. Okay, we can't possibly have this be 0. But it's also true that if we see plus 5 at the end here equals 8, then we need this part next to my fingers all to equal 3. And so we're going to have to come up with a way for that to equal 3. And again, I'm not saying this is exactly right. It's possible there's more than one way to do this. But we might, for example, try to think, okay, 6 minus 0 is 6. And then divided by 2, is 3, and 3 plus 5 is 8. And so it's possible that that's how it works out, but I'm going to leave the whole puzzle to you. And so you'll have to, you can make these little slips of paper yourself if you wanted to, or you can just use your eraser. But we got a couple of those sheets that are like that in your packet today. And then towards the end of your packet, there's this other puzzle that's intended to be a good thinker and also fun. And it's called Baseball Logic. And they tell you that there's 9 players on this baseball team. They give you their last names, and they play the different positions on a baseball team. And then it's like a logic puzzle. You're trying to figure out which player plays which position. And so it's just sort of, again, a thinker. And for example, it says Brown and Smith each won $10 playing poker with the pitcher, who is a poor loser in more ways than one. And so you have this sheet here that I've given you, whereas you can kind of cross out the possibilities. And so, again, it said Brown and Smith were playing poker with the pitcher. Well, that tells you that Brown is not the pitcher, and neither is Smith. And so I'll leave the rest of that kind of to you. But you just sort of go through and try to figure out what works or what's possibly true or what's impossible. It is true that there's, let me think, there's one spot at least where you have to know a little bit about baseball. Let me find it for you. It's this one here, okay? And it says, green is taller than the infielders and the battery. And so if you don't know this sort of baseball trivia, the battery is the pitcher and the catcher. And so that means that green is neither an infielder nor the battery, okay? And so that'll give you another clue. So infielders, of course, are the first baseman, second baseman, third baseman, and shortstop. So green is really an outfielder, is what they're saying. And so green is either left field, center field, or right field. Okay, well, I will leave that puzzle to you. And then this last sheet is just sort of a nice little fun math exercise. It's actually an old birthday card that somebody gave to me once, but it's the idea is you put your birth date information into these boxes as the instructions, and you should end up with exactly your birthday. It's a little math game for you. So anyway, there you have it. I hope that you have a productive day here in room 261 without me, and we'll see you after break.